So again, it saves you from bike shedding, saves you time from figuring this stuff out. You just literally download the SDK and you're off to the races on implementing it. But the life cycle is you initialize it, right? WebSocket, some kind of streaming protocol, which again, you don't have to implement. The package already does it for you. There's the APIs for tool discovery or capabilities of the MCP server, which again, you don't have to implement. The SDK already does it for you. You just have to write the code. The execution of the tools that you provide the LLM, right? The LLM will decide if it wants to execute whatever capabilities that you're exposing. And then the termination of it, right? The graceful shutdown of the LLM to MCP connection. All of this is taken care of for you. You don't have to write any code to implement the spec. You just have to more or less implementation details of what you want, right? What is the value that you want to expose? Great. Any questions at all? One thing too is, I know I'm being really fast about this and very shallow, but if you want to talk deep into it, let me know. We can go down the rabbit hole for a couple minutes. Yes?
I was curious, to discover it basically happens all over JSON RPC, or is there something like a spec that the LLM reads first, or like how does it work?
Yeah, it's all the RPC. So when you connect to it, and I'll show in the code, you have to call that tool, that discovery tool. Right, so at the end of the day, it's still an implementation detail. You have to write the code to, I guess, to tell the LLM what resources are available. Yeah. So the first integration point is in the front end. And so right here, I just write out, like, it's fun to do like an experiment and play around with the LLM, chat box and all that stuff, but you really have to think about what kind of a UX you want to provide for a user. And so just providing a conversational LLM is fun to do, but you get bored of it really fast because, right, everyone else is doing it. There's so many tools and tutorials online. And so think about like what exactly you want to do, because if you already write the code and then you realize, oh, you know what, I should have done this first, you're going to have to rewrite a lot. And that was my experience, is that if you just take some time off and think about, okay, what experience do I want when someone interacts with my chat box? What I want to do exactly? What kind of value, or why would someone want to interact with it? Besides me as a developer and having some fun with it, right? If I share it with a friend, if I put it online, what is the value add to it? And then go from there and design it, because it really goes a long way from just your basic copy and paste tutorials and generators online that you find. Anyways, so in the front end, right, I'm using Next.js app router. I'm using the Vercel use chat API. If you don't use a wrapper, you're going to have to implement yourself, right? And so basically, you're going to have to write your own chat management system. And by that I mean you have to write the code that manages the history of a chat, right? You have to manage everything, submitting, validation. Like, there's a lot of stuff that goes involves writing a chat box that, if you don't think about it, it is a lot. And if you don't use a wrapper, right, you have to be ready to write all that code to accept the chat from a user. And that being the first integration point, here's some code to show like how this is being used in the so is that readable? Somewhat. Okay, so use chat with the Vercel AI SDK, right? It's a wrapper that does a lot. And if you just look at it, the interface is small surface area. It is a hook, a React hook. And just be aware, if you do not use a wrapper, I don't know if there are other wrappers out there, you have to be ready to support all these APIs to get your messaging app, UI up to speed, right? And so it's a lot of work. It's a whole different conversation. It's a whole different topic. It's a whole different talk on implementing your own chat. So this is not what this talk is about. But if you use the Vercel, use chat, okay, we can get something done within a reasonable amount of time. So on the front end, the client, right, in the browser, it's going to run this code, right? And that's what you get here. That is the use chat. It has the handle submit is when the user actually clicks it, right? It clicks it, and it goes to this API. That API is the server API entry point. And so if you remember this diagram, we're talking about the front end, and that API chat is the starting point to the back end, front end communication. And Next.js obviously combines both into, I don't know, one framework, right? So you have to use the annotation use server, right? Your route.ts. So this component, calling it a chat interface, implements a couple of things. But the most important part is the form, right? Where the user submits the prompt and where the messages appear. And so a lot of time will be spent on how you want this UX to look like. And so I spent a lot of time trying to make it look and feel like OpenAPI or Perplexity, right? So if you start if you start all over again, the scroll area is centered, and then when you start typing, right, it kind of shuffles around. And as you continue to interact with the LLM, you get the scroll area that's very, I don't know, similar to look and feel of the OpenAI chat as well, right? Now, again, when you're looking at the front end, you got to figure out what experience you want, because it's a lot of refactoring that you do. That's even outside of the use chat implementation. That takes a lot of time to do. The UI exposes a token count, so you can keep a count of your tokens as you use. This first call, right, cost 2032 tokens. We can ask another question of, give me information about the React ATX database. You pop that. The state changes to streaming, yellow, and then green is ready, and the token count ticks up. So that question, right, cost me 12,000 tokens, right? And so right now I have a total of 14. So you get to see that these simple little questions actually add up really fast. The context window. And so the text area, you have the text area, and so when you're interacting with it, you hit this API endpoint. API chat. So we step over to the back end. The back end integration points are, I have two integration points. One is the priming of the chat. I'll get to that in a bit. And one is the actual chat. And then the two implementation details is from, again, if you do not use a wrapper that talks to OpenAI, for example, you would have to use OpenAI SDK and implement the streaming protocol yourself. And I have a working example of that in the repo that you can see. But for today's demo, I did use the Vercel wrappers generate text in the streaming text. Right? These are the 4 integration points that you might want to take a look at. From the view, from the backend view, we get to start interacting or start writing code for our MCP client. Right? And the 2 main classes is client, obviously, right? You have to create a client, and then you have to connect to the server using a protocol or a transport. And in this case, we're going to use a streamable HTTP client transport, right? So the MCP server is not on your local machine. The idea is it's somewhere in the cloud, and you're going to connect to it to the cloud. And that looks like the layout for Next.js. Well, I guess part of the MCP server stuff, again, think about it when you're building your front end. In React, you have this hook called useEffect. It runs after the component renders or mounts. And what this priming is doing, and the role of this priming is once a chat is rendered, let me see if I can, it's pretty fast, right? You see the yellow here? So what that's doing is I'm priming the context before I start having my conversation with the LLM. And so what that means is I'm going out to this endpoint, API chat endpoint, prime endpoint. I am going to get information about the database so that once the LLM is called, I can add that context to the LLM directly and save myself a trip. So it's kind of like part of the system prompt. And so if you look at the code here, we use the generate text API from the Vercel AI SDK. We're going to use the model OpenAI from their SDK as well. And I think to the question earlier is like you have to call the LLM, right? You have to implement the call that says, hey, give me your resources or something, right? In this case, I'm calling the LLM to give me a list of resources. How does that look like is in the list resources file, you have the actual client. You have a subscription to it. That's another thing that we'll talk about is the subscriptions to the MCP. But if you ignore that, there's a lot of caching and everything involved. But the magic line is here, is line 33, where the MCP client is the thing that you're talking to, right? The server, and then you call a command list resources, and this will call the capabilities of the LLM and return the list of resources that the LLM affords you. In this case, it's very simple. The resource I'm looking for is just database information, right? The data, I think I have it here in the prompt where this is a system context I'm using. I'm telling the LLM, hey, give me your database connection information, the URI, the name, and the user that's associated with the database, right? I'm priming the data. I'm priming the LLM. So it's not streaming the text. Generate text is just a one-shot payload, right? There's no streaming involved. It's happening behind the scenes, so that when the user starts chatting, it saves me a round trip, and it saves the LLM from calling more tools, which you want to do because the whole point is you'll see, if you do this long enough, you'll see context engineering is a real thing. If your context is shitty or lacking, you're going to spend a lot of time going back and forth with the LLM, and you're going to see your token count shoot up really fast. And token counts also associated with context, right? So your context window, you can literally see your context window like blow up, right? Hallucinations. And so context engineering is a real thing. You have to make sure that your context is legit. Something I learned along the way, having exactly the data that you want the LLM to represent or call is super key, right? I could have easily just said database information, right? Which will be insane if I did it, but actually this is how I was doing it in the very beginning, was get the database info, right? Yes, it worked sometimes, sometimes it didn't work, but just adding that kind of like the spec, I suppose, of what I wanted exactly made like the responses, I don't know, almost 100% of the time more reliable. So context engineering is a thing, and priming it is another thing that you might want to talk about with your team and how to implement or integrate with an LLM. After you're done priming, right, now you're back to the chat. Everything's ready, you're good to go, and we hit the other endpoint, which is the chat endpoint. So in Next.js, your routes are defined by the function method. So I'm doing a post. That post is going to contain the messages of your chat box. One thing too is that every time you communicate with the LLM, it sends everything over, right? It sends everything over to the LLM. So if your history is 100 messages, all those messages go to the LLM plus the system context as well associated with it. Keep that in mind. So priming and context, again, context engineering is a thing. LLMs are good, but you'll see the hallucinations, and it's kind of sucky. It's a downer. Anyways, again, you have to call the one thing too. If you do not use, or even if you do use, the MCP client, one thing is terminology. I should have brought this up earlier. Is that you will run into a lot of terminology that just doesn't make sense or is confusing. And one of them is tools. Everything's a tool. Everything in the client is what you call a tool. But in the MCP server side of things, there's capabilities, and tools is just one of those capabilities. But when you write your clients, you describe them as tools. And so I wanted to get resources from the database, from the MCP server, and for a while I was lost on how to do that. And it was just because in my head I was thinking resources, not tools, but the client references as tools everything. And so if you look at it that way, and if you implement your own, if you don't use a wrapper, you have to wrap your resource capabilities in a tool, right? It's kind of like this inception thing. Let's see here, resource tools. So I have two resources that I need to call that the LLM affords me. One is the list resources and the read resources. But in the client, they're called tools. And I have to follow a certain spec. I'm using Vercel AI SDK. They have a schema associated with it. So you have to wrap it in a particular way that obeys that Vercel schema. If you do it yourself, you have to wrap it in a particular way according to whatever SDK you're using, Claude, OpenAI, or any of the other dozen providers, right? Vercel has a general wrapper, right? It's a general purpose wrapper where it wraps all the providers for you. So it does a lot of work, but if you don't use Vercel, then you have to write per LLM provider wrappers, right? And if you want to take a look at how that looks like, just really quick, I have this file called __route. I don't use Vercel. I have a note here that says this is not a Vercel SDK. If you want to implement it yourself, you can pull the OpenAPI SDK, right? Use their APIs, but just be aware that you will be doing a lot of chunking, iterator, streaming, kind of like Node.js stuff, right? If you're unfamiliar with what iterators are or how to write streams, it's going to be a little challenge. Obviously, you can ask the LLM to do it for you, but this route file is, I don't know, less than 100 lines of code. If you write it yourself, get ready to spend a lot of time writing the minutia, right? Read streams, write streams, handling responses, validation, so on and so forth, right? So a trade-off that you do in the very beginning, use a wrapper or implement yourself. Just be careful. Just know that if you implement yourself, it's going to be a lot of work, a lot of maintenance. Wrapping the resources, back to the resources. If you use the Vercel SDK, you have to abide by their schema. And so what that means is that when you connect to your responses, right, this API call goes to the MCP, gets the capabilities of the resources. You cache in everything, but you have to return, you have to use their API or their schema in order for their wrapper to execute the tools. And this is kind of how it looks like. This is like the main schema that the Vercel API. You have the spec, right, the parameters of the tool, the description. This description is what the LLM is going to use to figure out if I should call the tool or not, right? This description is simply list available resources from the MCP server, right? In my prompt, there's another thing too, system prompt. Take a look at this system prompt. It's pretty big. It has to do with Postgres. But part of it, and the thing I want to point out is I tell it, hey, you need to call the list resources, right? As part of the prompt, I'm telling the LLM, every time you got to do something, you got to call this list resources. And so it's going to read list resources. Okay, so where's that tool for? Oh, it's right here, right? So again, context engineering is a thing. The more detailed your descriptions are, the better off, the higher the probability that the LLM will call the tool when it's more relevant, right? Keep that in mind. Your system prompts and your descriptions go hand in hand. The LLM is only as good as the context you give it.
How much of your token window did you use with that system prompt you have there? That's pretty long.
I think I log it.
Or you just roughly?
Yeah, it's like 4,000. Yeah. So you got the list resources, right? And then you have to read resources. This is actually the commands that you want to read a particular resource. I'll get to those specs in a bit, but back to the call, right? So you type in something, what database are you connected to? It comes here. We can look at the logs. Again, if you run it locally, I purposely loaded it up with logs so you can follow the steps that the application is taking. Here we see that the MCP is being called. It fetched 35 resources. The LLM did do a tool call. The tool results, right? These are your 35 resources that it got. Next.js logging. Let's see. And then the tool call results are fed into the LLM again, so the LLM can summarize it. And it spits out something in English or something. Oh, I got an issue. Did I change something? Oh, I'm not connected to the, I got booted off the Wi-Fi. Anyways, let's do that again. Priming, yellow. Okay, it's ready, submitted. And if you really want to look at the logs that are being returned from the LLM, you can come in here. I think I can just add it here. Right, this will print out like that payload that's actually being communicated with the LLM, so you can get an idea of how this thing is being consumed. The communication structure between the LLM and I guess the backend service and the tools, right? The flow. I guess the there it is. Okay. So you print it out. Wrong terminal. Here we go. So this is the context that's being sent up, the request body to the LLM. And you see it has all the Postgres stuff that I showed, right? And then it has the priming information as well. And it affords the tools that the MCP has as well, and the schemas associated with it, right? So that if the LLM does use a tool, it provides the right schema for the parameters to be executed. But anyways, take a look at that log, and you can see what's being transmitted on every single request, and this thing just grows, right? Because it's stateless. It's a stateless protocol, so you're transferring one giant payload back and forth, and it grows linearly. So context engineering is a thing. In this case, I'm using the stream text API, right? That's the integration point. I'm using the model. Again, stream text API, if you don't implement yourself, you got to write your own implementation. But it's pretty straightforward. Vercel's very good documentation on this. It doesn't implement all the tools, and it's missing some subscription stuff. Anyways, but it's pretty good. And if you can use reasoning as well with it. I'm not using reasoning, but I do have steps, so that if it can't answer the step, it can't answer the question that I ask the first time, it can go back again and prompt the LLM behind the scenes, right? Multiple times until max steps is 5, and then it barfs out some answer saying like, I don't know what you're talking about, right? But again, context engineering is a thing. That's the main takeaway for tonight. But something I learned along the way is max steps 5 is pretty good as a boundary. If you exceed that, then maybe it's time to update your context, right? Take a step back, reread your context, pass it through some context or prompt optimizers online. Try to figure out how you can optimize it, because if you're asking a question and it's taking the LLM more than 5 steps to answer, maybe it's a good time for, in my case, the threshold that I use to like, okay, I have to do something else with it, right? Because at 5 steps, that's like 20 seconds, right? Is that the UX you want your users to experience? Think about that. And so right now, this is the back end, the entry point to the back end, right? And the entry point calls the list tools from the MCP in the get database information, which that database information gets pumped into the system context, right? The system prompt, the main prompt associated with it. So when you ask a question like, what database are you connected to? The LLM has it in this context, so it can save you a round trip from asking the MCP server, right, to get that information. It's already within the context. The description of your database, in this case, is already part of the system context, so the LLM can plug that answer rather than going to the MCP server and asking that question over and over and over again. Again, context engineering, you got to think about what, how can you save yourself a round trip and tokens, right? So if you ask the same question in a different way, is tell me about the URI of the database, right? So this, in theory, right, you just pulled it from this context. I should turn that off. So that's the, okay, so I'm connected to the database. That was the other call. And then I asked it, yeah, so it didn't call a tool, right? It just read it from its own context, that the URI was this, and it just popped it out, right? So it saved you saved yourself 28 tokens, or prompt tokens 2,000, completion tokens 28, right? Versus this plus the MCP call, and then integrating again with the LLM, right? You can easily blow it up to like 4,000, 8,000 tokens right there, right? So again, you got to think about how you do your prompting, how you do your context, what information you expose right off the bat. Once you have the connection to the LLM, right? This is the LLM to your backend conversation. We can take a look at the client information, how the MCP client is connected. And that is in the library MCP folder client.ts. Here is where we pull the client classes and the streamable classes. Again, I'm using the SDK, which implements all this stuff for me, right? I don't have to do anything. It's very straightforward. You provide the MCP server that you want to connect to, the transport, in this case, the streamable. If you're doing this locally on your laptop using like standard I/O, then you'll use that transport, standard I/O. In this case, right, we're using a remote server. So the transport between the calls is going to be HTTP. You instantiate the client. And very straightforward, right, is the call. You connect it with the transport that you want. All that dancing, initiation, lifecycle taken care of for you, right? You don't have to, there's no implementation, it's just the call that you have to write. The stuff that I wrote around it is just because in Next.js, in dev mode, if you know Next.js, I guess it's just in React in general, it executes twice. And so in dev mode, and so that kind of jacks things up while you're development. So this just wraps it in a promise. If a connection is in progress, just reuse the connection, right? So you won't get those errors in the Next.js console. But other than that, it's it's trivial to connect to a client, to a server, right? You just need a URL. You define the transport. You instantiate the client, and then you do a connection. That's it. You're ready to connect to it. Once you have that client, you can reuse, right? You can slap it in whatever interface that you want to interact with. In my case, I'm using, I use this proxy. I define this proxy. Again, implementation detail, you don't have to do that. You can do it your own way. Either way, once you do that, once you have your client enabled, you just import it wherever you want to use. Whenever you want to talk to the MCP server, you just import that client, and you use the APIs that come along with the SDK. And so resources, tools, prompts, sampling, there's other resources. Let's see if I have them here. Routes, solicitation, these are all capabilities that the MCP affords you. And using the SDK, you can just call these methods out and start interacting with it. But the point is, you have to write the code to trigger the call to the MCP. Right? It doesn't do it by itself. You have to call the MCP. So this is very important because the way that you structure the MCP is crucial. There's a lot of generators out there that will just throw everything inside of it and have at it. And that's great. You can get up and running, but again, you're going to see your token counts blow up. So if you're very deliberate about the resources that you define, you're very deliberate about the tools that you define, it can go a long way with keeping your token count low and the user experience, right? Saving round trips and all that good stuff. So in this case, the MCP client has this API called read resources. So let me jump back to the slides real quick, right? MCP has modes, right? The standard I/O and the streamable. Oh, another thing too. If you used MCP before, they've deprecated the server-side events, right? So if you have code or you use a generator that's pre what? 13, is it? Yeah, the thing is 13, is it 14 and above? If you have anything 14 or below 14, you are already, and you're using server-side events, it's already deprecated, right? They have a whole reasoning behind it. Check out the blog posts, right? Things are moving really fast. Things are changing all the time. But you get to see why they deprecated SSE and went with something called streamable HTTP, right? Check it out. Stay up to date. Update your code, right? A lot of the generators online are not up to date. A lot of them still use server-side events, and I'll show some later on these generators. Okay, those are the modes, the capabilities of an MCP server that you program. Business value, right? You got to think about it. What are you going to expose? So what are resources? So an MCP is going to provide resources, but what exactly are those things? And they're just data. Data you're going to feed context into the LLM, right? So the LLM is going to receive some kind of resources about the service that you're providing. In our case, it's a database. So think database information, schemas, tables, table schemas, columns, types, foreign keys, constraints, things and stuff like that about a database. Those are resources that if you want to generate complex queries, the LLM needs to know, right? And they're all defined by the spec through this URI, right? And so if you look at the examples, these are kind of like the URIs that the LLM will call into to pull information, right? To fill its context up, to help answer your questions. And we're using the Postgres database customer schema. Now, these are examples. You don't have to define them this way. You can write your own URIs. But as long as you slap a key that says URI, it's going to be respected, right? In this case, it says Postgres, right? I think in my URI, I use PostgreSQL, right? The LLM and the MCP don't care. It's just that you front it with a URI is this. And again, this is just context loading. MCP already exposes these two APIs, a resource list and a resource read, right? And this is exactly what it is. List is just give me all the resources that you have access to. And then if the LLM decides to use one of those resources, it will call the API resources/read with that URI that points to the resource, right? So think about like APIs. We all write API endpoints. The URI here is pointing to a resource, a file, something that it can pull information out to help answer the question that you're prompting. Whoops. tools. So what are tools, right? If in the client, everything's a tool, but in the world of MCP, tools are very particular things. And these are just actions, things that MCP can carry out, tasks, right? Performing computations, right? They are uniquely identified, if that means anything. But there is, and this is very important, metadata describing the inputs of that schema, the schema describing the inputs of that tool, and then an output, right, schema, so that the output of a particular tool. I should point out that an MCP itself can actually connect to an LLM model as well, right? You can write an LLM inside your MCP that's independent of your backend. So early on, for this Postgres MCP, I had an LLM that was fully loaded with everything associated with Postgres. And MCP, when it received a request about resources or something, it will always consult the LLM professional inside the model context server. Yes, that is wasteful. You need to do that. But it is an architecture that you can implement. I think there is reasons to do an LLM inside your MCP, but for all intents and purposes, this demo does not have that architecture. But there's nothing there's no rule that says you can't do that. And there's no rule that says you can't integrate multiple LLMs into your MCP to help answer questions. And if you do go with that architecture, things start to pop out. You start asking questions about scalability. You start asking about, or maybe building your own MCP gateways, right? Where this MCP tool integrates with a dozen of LLMs who have access to other MCPs, right? So you see a little bit of imagination. You can see like, oh wow, agents to agents, right? You see these things, these concepts start coming about. The tool list, right? The LLM, if it it needs to call the list of tools, or sorry, you have to write code that calls get list tools, right? That feeds into the LLM. The LLM then has these particular schemas of your tools that it has access to execute. And then when the LLM wants to use a tool, it calls the API tools/list. Right. Again, this is all in the MCP protocol documentation. And then prompts. Prompts are just what we've been doing all the time, right? They're just already pre-configured concepts or text that an LLM call. You feed it a prompt, right? And so I guess you can do like to enhance certain queries. You can use these predefined prompts of what's the best way to write a query that will join, multiple tables, and in what format do you want that to be generated in, right? The prompt can add extra context to the LLM. And again, these are all very structured APIs, prompts lists, and prompts get, right? You afford the LLM a list of prompts that it has access to, and the LLM will call these tools, right? We'll call a prompt if the description that you give it is something that the LLM can use. So one thing too I didn't mention is the session management. You can have MCP servers in a stateless mode. I think by default the examples in the MCP repo. They have stateless and stateless and stateful examples. Stateless is more for if you have your MCP server in a like a Lambda function, and you have session management handed off to something else. The example implementation of the Postgres has a session management, and with that, right, you got to think about it. Why am I doing session management? Because if a user connects to the database, right, I want to make sure I save that. I want to keep a track of the history of the user, right? So I can write, maybe upgrade my chat box, right, to have like a little history section. Definitely want to cache the schema information, right? You don't need to keep calling the database for the schema, right? The schema rarely changes, right? So you want to keep that in the session management, and obviously the ongoing conversation history of the front end. And so back to the code real quick. This is if you look at the repo, the implementation of the server, MCP server, is under the folder called Z MCP. The Z there is just so like the folder can fall at the very bottom. Just organizational, so ignore the Z. Anyways, inside this folder, we have the starting, right, the initial stuff, the server connection. So in the MCP server, right, we call it a server, but it's not in the server sense, right? It's one of those terminology things. The MCP SDK server doesn't implement HTTP, right? There's no node HTTP implementation here. You have to write your own not protocol. You don't have to write your own transport. You have to integrate a server with the transport, if that makes sense. So the examples online always with Express, right? You have to expose the MCP server through a server, HTTP server, right? It's against the confusion of terminology. The MCP itself is not a server per se in the way that we think about it as application developers. You have to either use Express, I've used Fastify here, or implement your own node HTTP implementation. But whatever you do, you have to wrap it in a server, in a HTTP server. And once you do it once, it's set and done. You rarely have to touch it again. Again, I use Fastify. You add things that are particular to Fastify. But the most important point is you have to expose these endpoints, right, /MCP. And that's just a standard, right? In the documentation, I think before it was /SSE, but that's been deprecated. Now it's /MCP. And there's 3 methods associated with it. The delete method is only there if you do session management, right? Again, the documentation can go into it. You do have to integrate the transport. So this is where the MCP server affords you. You define the server with your capabilities, right? This server is going to have resources, it's going to have tools, and it's going to have prompts. If you only want to expose resources, then that's what you do, right? And this is part of the initialization connection between the client and the server of the MCPs. Again, very straightforward, similar to the client. Everything is pretty much taken care of when you do this connection. You instantiate the server with the capabilities. You get back the object, and then you register your capabilities. In this case, I'm registering the resource handlers, the tool handlers, and the prompt handlers. The main takeaway is you just have to follow the spec. You have to follow the spec when you implement these handlers. And then you initialize the Fastify, and I think it's in the index of this folder is just the starting of a server. So if you have implemented any Express server, right, there's nothing new. The only difference here, I wanted to do this with containers in mind. I still have to update it, but I wanted to start, the server will only function if it's connected to the database, right? So I initialize the database, I prime the cache, again, the context, and then I expose the server to the outside world. Right? Very simple. This is just an opinionated way of doing things. Again, Fastify, also opinionated way of doing it. I don't think there's anything here. The magic happens in the session management, right? Session management, because every session is associated with the transport. Every user, right, is associated with the transport and the database. Again, you don't have to do session management. You can do stateless, which is a different implementation. But I think eventually you're going to have to go stateful, right, for MCPs. Anyways, it's very straightforward. You define your transport again, which is HTTP, streamable. The SDK already provides a what do you call these? I guess unique identifiers for your sessions. You just have to write the options for the transport, and everything else is just taken care of for you, right? Whatever the transport is, it's fed into your server. In this case, Fastify, which again you don't have to write, right? So think about streaming, chunking, pagination, all this other stuff that you would normally go into writing a HTTP server. It kind of just goes away, and the model context protocol hand waves for you, abstracts it all away from you, where it literally just takes like 3 lines of code to get it working. That's the session manager. And so once that's connected, now you're ready to interact with the affordances or the capabilities of the tool, of the MCP. And so quickly, if you look at the implementation of the read resources, for example, or the get resources, I try to organize the folder structure in a way that's understandable. So the MCP folder has the tools or the capabilities. Because this is a Postgres database, the resources are all, well, guess it. They're all queries, right? Queries that you will ask your database about. And so list the schemas, right? It's going to come back with the list of the schemas, right? Tell me the tables associated with the community schema, right? It's reading the resources and it's calling the MCP, and then tell me about the speaker table, right? And so it provides this information associated with it. It tells you the indexes and the constraints, right? There's no foreign keys, so it's standalone. Stuff like that, right? And so those queries are generic. You don't have to write them all the time. There's no ORM involved in this. It's just a single SQL query, database, right? These things can get as confusing as you want. You can create these resources with, again, arguments. So this database name will be populated by the LLM call, right? When the LLM calls this function, it will make sure that it passes these 2 parameters into this function, right? The URI string and the database name. If we jump over to the registration, how does it look like? So in the slides, there's APIs associated with them. These are the APIs. There's generally 2 APIs you have to implement. Ignore the third one. The 2 ones are the list, the resources, list the tools, list the prompts, list whatever, right? And then the particular get, or the call to action, which is usually a read, a get, or a call, or get is for prompt, right? These are the 2 main APIs that you'll always implement. And once you implement them, you write the resources that you want to afford, right? There is a particular schema that you got to follow. For example, the database user resource, right? You have the URI, you have to follow that pattern, that schema. You give it the name, because the name and the title and the description will be fed as part of the context to the LLM. The more detailed and specific you are, the higher the probability that the LLM will call the right resource. So you list the resources here, and then you implement the handler of like, okay, so now you afford the resources. How does the LLM call it? You call it through the read resource request schema API, right? And resources all take a URI format. These are the URI formats that I implemented. And again, the URI is being passed by the LLM. The LLM knows which URI to send over. And so if you look at the read resources functionality, right, I cache the data. Again, you don't have to query the database all the time for the same information over and over again. And then you implement the if statements, right, of like which URI to figure out which URI a resource to pull from. And these functions are all queries. Right? All these functions execute queries to provide the resources. And the same thing goes for the tools. So in the tools, I have a query tool. So let's generate a query that returns all the speakers. Right? So it's going to generate the query. And again, think about how you want to implement the UI and the UX. I wanted to implement the UI in such a way that if the LLM does generate a query, I wanted to format it, and I wanted to provide a function so I can run it and see what happens, right? And so I'm going to run it. It's going to call that tool, right, to execute the query that it generated, and it's going to return the information from that query, right? And this thing can become pretty complex. So generate a query that joins the speaker table with the presentation per speaker. I don't know. Let's see what it will do, right? Well, that was pretty fast. Cool. And so you run it. And it's telling me, wait a second, you have to replace the speaker ID with the actual foreign key that you want. So, okay, so I wasn't very clear. Return, so generates a query that joins the speaker table with the speaker for all speakers. Let's see if that clears it up a little bit. Right, so, okay, so there's no foreign key associated with it, so it's going to do its own thing. So, okay, is there a common field link speaker? Assuming the speaker ID in the presentation table, here like this. Okay. I have to respace. Okay, so you go back and forth with the LLM, right? Try to figure out what is the prime, the query that's, and actually I don't even know. So let's see, generate a query that returns the news items. Should be something simple. Okay. Anyways, so I'm already at 100,000 tokens on this context window. Right. So if you look at the query tool, again, I tried to write the code in a way that it's kind of simple to kind of grok when you just look at it. Again, you're always going to implement these two APIs, a list tool and a call tool. The list tool, right, it just returns a list of tools that you follow a spec associated with it. If you look at that index, the list tool is just one tool. It's called query tool. If you look at the query tool, and it's just, this is like the description of the query tool, right? The name, you run a read-only SQL query. That's very important, right? You've seen a lot of examples online where people are freaking out. It's going to mutate, delete stuff. Even though you tell the LLM it's a read-only tool, obviously you want to write safeguards so that if a query is generated and is executed, and it does have side effects, mutations, or is trying to get information from the database that is not allowed to get database information, you want to have to catch it, right? And so because this is a database, you have to write certain particular filters, I suppose. And so this implements this SQL parser, again, particular to Postgres. So when it does get a query, right, I don't know if the LLM's query is legit or not. So there's 4 things I check for. There's no statement chaining, if you're familiar with SQL. There's only select statements, right? You want to make sure that there's no insert statements, no update statements, no delete statements, no copy statements, right? Right? You want to protect your database. Forbidden schemas. Do you want to allow the user to have access to all the schemas, particularly the Postgres schemas? Maybe, maybe not. In this case, a PG catalog, you're not going to be able to write a query that has PG catalog inside of it. And then on top of that, you want to make sure that no query has access to the file systems or the network, obviously, right? Again, you write this code. You don't leave it up to the LLM and have faith that's going to write the query responsibly, right? You always want to double check. Just like we always tell new developers into the development space is like, you always validate on the client, you always validate on the server, right? Regardless, you validate at both ends. The same thing here, right? You write the guardrails in the context for the LLM, but it's like trust but verify. In the query, in the actual tool case, you want to validate exactly what's going on. Make sure that you don't want to screw your database, right? And so it just does a bunch of checks, function calls, mutations, all that stuff. And then ultimately, a limit, right? You don't want to write a query that returns 100,000 rows, especially when the user interaction is a chat box. This is not really good experience or interaction with the database, right? We're usually seeing the tables and rows. In this case, it's just a JSON schema or a JSON payload, right? And so if you have 100,000 rows being returned, this is not really good UX for that. And so the last line of defense is, okay, a default limit of 10, a max of 100, right? Just to check yourself. Again, if you play around with this, you can change the numbers as you wish. And then the actual execution of SQL, you have to use a database driver. I'm using Postgres.js as my driver. Right, again, very straightforward. Postgres.js is pretty popular. Nothing too out of the ordinary. And that's pretty much for the tool, right? This is the tool that's going to take the query and just run it. And then return the results, right? And there's only one tool, only one actionable tool in this MCP, which is the query tool. Just execute the query. And so you got that. So one last thing I wanted to talk about is this. If you, I don't know, as a backend developer, as a full stack developer, I use OpenAPI spec a lot. The tool that I'm writing, Synapto, uses OpenAPI spec a lot as well. JSON schema is the foundation. And so once you go into the space, you get introduced to a lot of generators. A lot of generators out there that, a lot of companies, a lot of open source generators that promise you that if you give me an OpenAPI spec, I will generate the MCP server, right, that connects to those APIs for you. And an initial thought is like, wow, yes, this is exactly what I want to do. And I want you to think about this very carefully, because the LLM, if you flood it with context, it's going to more likely hallucinate and return junk. So if you have 50 APIs with some kind of description associated with it, and some of these descriptions overlap, guess what? You're going to confuse the LLM too, right? And so these generators, they just take all of your APIs and create this MCP server, and then you have to come back in there after debugging or trying to figure out why the LLM is not calling the right tool, or why the LLM is not calling the right MCP API. It's because you have swamped the context. It's going to generate slop, right? It's going to call random tools. It's going to go in the loop, and you're going to hit your max steps trivially fast. And so I researched 5 of these generators. They're all different. Some of them put everything in one file. Postman does a little bit more organizing, but again, it loads all your APIs. In the canonical example of the pet store, that's the one I used to test all these. And it's cool to see how fast and up and running you can get, but it's also very interesting to see how really confused your chat box is going to get. You can see that in real time. You can see the token count just blow up because it's trying to figure out what to do with all this data and information. The speakeasy, I would say MCP is pretty good, but you only have like 14 days to try it out, and they don't connect to your APIs. They write mock endpoints for you, right? Another business decision that they took. Stainless steel, stainless steel is a pretty good one. They provide a wrapper, which I thought was really interesting, context wrapper, right, to enhance your APIs. But again, because every API becomes enhanced, let's just say, you flood even more your LLM, right? Context engineering is a thing. You have to be aware of this. If you're just going to load up your APIs, guess what? You're most likely going to hallucinate, or your LLM is not going to call the tools that you expect them to call. Now, I guess let's do a quick recap, and I can show you the code. So the survey covered, the front end. There's a lot of work to do on the front end of connecting the use chat. The back end endpoint, right? You have to expose an API chat. If you take a step back and you think about how you want the UX to be, you might have to expose other APIs before the actual user begins to interact with the LLM. There's the LLM integration using the generate text or the stream text API from the Vercel SDK. And then in your MCP server, you have to use the streamable HTTP protocol or transport, and then connect that to a server to expose the standard /MCP endpoint, right? And then once you establish and build that server, you have to go in there and write the APIs associated with the resources, listing the resources, reading the resources, the tool calls, right? List tools, call tools, and the prompts, and the list prompts and get prompts. And all this stuff, right, behind the scenes, that's completely abstracted away from you, is connecting to the thing that you want to connect to, right? In our case, it was a database, so I have to use a database driver for that. If you use one of these MCP generators, then that resolver is generated for you. If it's not to your liking, it's using Axios instead of fetch. You got to go in there and change it yourself, right? And then on top of that, MCP is changing so fast that, again, this stuff that I presented today is probably out of date as soon as I'm done talking, or at the end of the week, or in a month from now, right? Especially when it comes to the security aspect of it, which I didn't even bring out because they're LLM call, yeah. You have to protect. You can't let the LLM just do all your what is it called? Your best blind faith in an LLM, right? You can't do that. Integration points. There's a lot for a full stack, right? And every single one of them is pretty deep. But once you see the pattern over and over again, it's almost second nature to like how we build APIs today, right? API, you have path, you have queries, you have headers, you have request body, you have a response body, right? If you do them enough times, you just memorize them and you just go with them with the flow. From my experiences with MCP, they're pretty memorable. The hard part is figuring out what the hell you want to use it for. Like what exactly is the MCP going to afford the chat box, right? The interface. I wanted to briefly cover the security, but obviously once I had the code and everything, I had to take it all out because they just came out or are about to come out with a official guidance, standard, what have you, on how to integrate with elicitations. So if you're interested in that, check out the PR. It's still open. It's just, an hour ago, whatever, right? People are still debating it, but it's pretty much set in stone that it's going to be implemented. And you can check it out. They have a very good blog post. July 11th, a couple of days ago, right? MCP gateways, right? Our simple little use case is the MCP. Again, you can have multiple MCPs in a company. If you integrate with GitHub, with Cursor, one question I asked myself is like, how the hell did they create one MCP that does all these things? In reality, I'm pretty sure they're using some kind of gateway that directs the LLM tool call to a particular MCP, right? So if you know API gateways, right, MCP gateways is not that stretch of a mental model. Again, changing tides. While I was writing this, a lot of stuff I found online was just like, holy shit, this is really hard, right, to keep up with. Context engineering, right? We all heard about prompt engineering. I guess now it's context engineering. I kind of vibe with that better, context engineering. Right, priming the LLM is probably key to receiving a response that you expect. This research came out not too long ago, context rot. And so it doesn't matter how big your input tokens are, right? So like Gemini has 1 million tokens or something like that. This research goes into saying like, hey, even if you have this huge, massive context window, it tails off really fast, right? The quality of the output goes down. So context rot is how they're defining it. One thing too that I think LLMs, right, large language models, something to keep in mind, I think will actually be more popular is the small language models, where these small language models are, as you guessed it, very specific to a thing, right? So imagine having a small language model 100% only does Postgres, right? It doesn't do anything else. It doesn't reason about anything else. It only does Postgres, right? And so the responses from this model will be, super specific, right? Where you can kind of like feel very comfortable and very confident that the questions that you ask about a small language model implementation is probably more precise than using a large language model, right? Again, something to think about that I ran into. And then also these things called edge language models, right? Everything's on the edge. We want to put these language models on the edge, but what? They're too big, right? So you got to shrink them until they're edge language models. Again, something to keep in mind. The field is vastly undefined, constantly evolving. And so it's just really tough to go into this. What does the future look like? Recommendations, resources, and before that, really quick, I wanted to show you the really interesting part of all this is okay. If you look in the, I haven't pushed this branch up yet. I haven't merged it. When I merge it, you'll see this. But this is what you get when you just throw APIs at it, right? In this case, I threw a pet store implementation of it, right? Depending on what generator you use, you have different results. But at the end of the day is every single API, it gets converted to a tool, right? And so you can imagine this just growing and growing and growing and growing and growing as your tool set. And then you look at the tools, right? And I tried to organize them in a way that it makes reasonable sense. I don't know, grab by status, right? They all follow the same patterns, and that's why these generators are very popular, because once you establish a pattern, right, you can just ask the LLM here at cursor, right, hey, generate another one, or so on and so forth, very consistently, because it's going to use the examples that it has access to. But you expose, you generate a metadata associated with the API, right, the Open API spec schema. You give it the tool schema that's associated with it, right? Again, the LLM will generate this for you, and then you call it, right? Some kind of handler to call. So, and when you do that, the call, the inputs, right? The LLM will make sure that the input schema is satisfied. So if the LLM is going to call this API endpoint, it's going to make sure that the status is provided as part of that contract. And so this pattern, once you establish this pattern, all these tools have the same pattern. All of them. So it really brings back the focus like, okay, what is the business value at this point? Is it throwing all my APIs in this microservice? Or is it combining them into one API, creating a workflow of one API hits another API, hits another API, right? So you got to think about these things. And a lot of examples just give you all the APIs, and you're off to the races, and you feel good until your LLM starts giving you crap, and you're trying to debug it, and it's a black hole. Anyways, that's kind of all I have for right now. Is any questions? You want to talk about any specific detail about MCPs, or any such things?
It seems like maybe one use case for it, if you had like some kind of operation which is slow and GUI, you might be able to like make it MCP for it that can do it a lot quicker or something. Has that been your experience, or what kind of tasks have you had success with?
Well, this Postgres one, This Postgres implementation is a shadow of one that I've built. So in the UI, again, it always comes back to a UI. So when you're querying a database, right, and you're trying to think about it like this, are you a backend? You've written APIs before?
I use like Postgres, database.
Postgres? Yeah, REST, the REST. Yeah, yeah. What about, do you use an ORM?
I actually don't use ORM myself.
All right, join the club. I don't use ORMs either. And so because of that, I'm always writing queries. And because of that, I'm asking the LLM to generate the queries for me. And one of the things is, for me, is like, this chat is a great interface when I'm trying to discover stuff. But for repeatability over and over and over again, I would rather just have a button that if I forget the schemas, I click on it, it just shows me the schemas. I don't want to type out, show me the schemas, right? It's kind of dumb.
You can't just keep one.
What's up?
You can't just keep like, I usually just have a text file with schemas.
Well, yeah, you can do that too. The tables, right? Or I'm joining 2 tables or 3 tables or 4 tables, and I want to write a function, right? A stored procedure. I have to do research behind it to see if the tables, match up. And then once I get the data, I want to do 1, 2, 3 inserts, stuff like that, right? And things you want to do really quick. The chat box is, I would prefer to have like buttons or call to actions that automatically do things that I do very, very often, which is just trying to figure out if I can join 2 tables or not. And rather than me typing out a long-ass prompt about, generate this and generate that, because at the end of the day, when you write these like functions in store procedures and you're doing complex stuff, you'll zip through your tokens. You will consume your tokens so fast because the LLM is trying to figure out all this information. And it's calling resources, it's shoving stuff into the context, to the context window, and then starts spewing stuff out that doesn't make any sense. And then you got to redo it again. And so like, if you have the information up front, like through call to actions, it makes it a lot easier to give the context to the LLM, like, hey, this table and this table and this table are related through this foreign key. You don't have to go and call 5 different resources to figure this out because I'm telling you, right? So those are like small things that I have found out when I made a MCP for Postgres. Is like, there's small things that I just call to actions that I wish I had, and I built in the Synapto UI that I can just easily probe, right? So it gives me context to prompt engineer, right, to feed it a better prompt, rather than leaving it to the LM to figure things out by itself. There's another MCP that we implemented. It's an API MCP, and that one spews out Open API spec. Now, do you need MCP? Do you need MCP serve for that? No, you don't. You can ask the LLM to do it for you. But just know for a fact that if you call the LLM and you're not validating that it's a validated Open API spec, then you're going to copy and paste code or JSON schema that's going to break down the pipeline. That's just waiting to break because you didn't validate it. And so if you write it that way, if you write your LLM that way, you have to make sure that when the call from the LLM comes back with the generated Open API spec, you have to feed the result into a validator of some sorts. Whereas if you just have an MCP and you just feed that tool to the LLM, it's always going to call a MCP, and I don't have to worry about it. I don't have to write a special code for it. It's reusable. I can use this MCP in Cursor right, to connect to Cursor and generate my open API spec there. I don't have to worry about it being valid or not. It's always going to be validated. I can see the logs, right? It's another example where the MCP really helped out. And the third example that I have right now that I'm finishing up is, so the tool Synapto itself, you can trigger a simple command and it will generate an API, deploy it, write tests, and document itself, right, in one call. And so I want to make that call available to an LLM so that if you're in Cursor, you can just say, hey, I want to generate an API for my users and give it a user ID in the path parameters, right? That's it. A very small prompt. The LLM goes and does its best to create a open API spec compliant. It will connect to your data source because it knows your data source. It will generate the query, write the query, run the query, and kind of like build it out and then deploy it. And then the output is a link, a hot link to your to the API that the LLM just wrote, right? And so the MCP server in that case, it's the only responsibility is to call one tool, but it needs to have the context associated with the tool. So it calls the API MCP, and then it calls the Postgres MCP, takes that data together, combines it, shoves into the Synapto tool, and generates the whole thing. But at that point, right, this MCP LLM calls are pretty taxing, and so you start writing agents. Like this concept of an agent comes out, and agentic workflows, and it's like, oh, okay, now you see this, you see that. But again, the UI is a chat box, right? And to be honest with you, I don't know what the solution is or how it looks like, but with this UI, I was just playing around with it, right? I want to have a dashboard that has cloud management, like AWS. It has a chat box associated with it, but you need to have other pieces around it, right? It's not going to be a chat box to it. So it's still exploratory. I'll push my updates to the repo, but what are the call to actions, and is this simple chat box the future of like I don't know, LLMs? I don't think it is. There's something else. It's just part of it, right? You need these call to actions. As a developer, you want these tools to do these multiple things. You want to feed it the right context. You want to feed it the right prompt to get the most accurate or most relevant answer to it. Because leaving it to itself, I think, is too loopy. I don't know if that's the right word. Anyway, it's a long-winded answer. Any more questions? We can talk downstairs. Oh, it's already 8 o'clock, yeah. All right, well, let's go downstairs and let's continue the conversation. Oh, don't forget the parking tickets. Parking tickets. Never again.
Cheers, guys.
Can we have 1 or 2 volunteers to help out with the chairs? That'd be great.
Thank you.
Yeah. There you go. Nice shirt. Oh, yeah, of course. Yes. There you go. What's up, man?
Cool stuff. Just wanted to say hi until we go back. I was just late to all the pre-presentation thing. I was late a bit to your.
It's all good, man. It's a busy day today. There's a lot of good
Yeah,
talks.
I already missed the last 2, so I was like, I have to. Especially when I saw you be doing the like survey on MCP. I was like, yeah, this one. I'm not scared. I'll probably be sticking to you for half of the evening. I have so much questions because I'm literally doing the same task for myself. Like accept, reject. Yeah. So I like your SQL snippet where you have many of this one. Oh, so that's so we have like the check box, right? Like everything inside and everything